Good morning, students.
Good morning, teacher.
Are you all ready to learn something new today?
Yes.
Good. In fact, I want to share something interesting with you. Yesterday, I had gone with my family for an early morning trek in our village. I took some video, which I'm going to show you from the Kayan. So what can we conclude from what we have seen just now? It was light that helped us to see. As long as there was no light, there was no sight. We could see better and better as the light became brighter and brighter. This is how planets too become visible to us, all due to the reflection of sunlight from their surfaces. We have some animations depicting the planets in our solar system. Let us visit our portal. In the address bar, enter www.ilfsets.com/Gyan-Sadhana. Type your registered username and password. Click on the tab Upgrade Your Knowledge. From the left column, select Physics. Then, select the module Light. And then the topic Reflection. Under Reflection, select Lecture 1, Laws of Reflection. Click on the No More section to view the animation. Let's take a moment to recap. Light is a form of energy. We never see light. We see objects because of light. When we hit a ball on the table, it bounces back. In the same way, when light strikes any opaque object, it bounces back. If this bounced light reaches our eyes, we can see the object. We can see only if there is light. When light from an object reaches our eyes, we can see the object. Do you want to know how our eyes work? Log into the portal and proceed to the lecture page. In the No More section, click on the hyperlink to see the eye animation. Students, do you remember the story of the clever rabbit and the foolish lion? The smart rabbit took the lion to a well. He asked the lion to look into the well. The lion looked into the well and saw his own face in the water. Thinking it to be another lion, he roared, jumped in, and drowned. Wasn't that an interesting story? There is an interesting piece of observation in it too. The lion could see his face only in the water, but not anywhere else. What is so special about the surface of water that made the lion see his image in it? Let me explain. Look, children, I have a dusty shoe in my hand and I cannot see anything in it. There is another shoe which is already polished. It is smooth and shining. Rahul, come here.
Yes, sir.
Can you see some images on the surface of the polished shoe?
Yes, I can. But though I have not understood why I could see the image on the polished shoe and not on the dusty one.
The smoother the surface, the more it shines. So you can see an image on a polished shoe, but not on a dusty one. Let's look at another example. Look at this white paper. It is dull and does not shine. Rahul, do you see your image in it?
No, I can't.
Now here is a glossy paper. As light falls on it, it shines. Rahul, compare the surface of the glossy paper and that of the ordinary white paper. Do you see any difference?
Yes. Glossy sheet is much smoother than the ordinary white paper.
However, you cannot see any image on the glossy paper.
No, I can't.
On the other hand, if I take a plastic sheet and look at it, what do I see? Rahul, can you see a blurred image on this?
Yes, I can.
Perfect. the plastic is much smoother than the glossy paper, so you can see some kind of image on it. Let us go back to our story. The surface of the well water was smooth and still. The lion could see his face in it. The surface of the ground or the wall of the well was rough, and so he could not see his image there. So images can be seen on smooth, shining surfaces and not on dull, rough surfaces. Does a light ray behave differently when it strikes different types of surfaces? Let's now understand why it is so. When a ball is dropped vertically in a straight line, meaning perpendicular to the surface, it bounces back in the same direction. Similarly, if the ball is rolled on a flat surface, it hits the surface and rolls back in the same direction. Now, if it is rolled at an angle to the surface, what happens? It hits the surface and rolls back in the opposite direction. As it rolls back, it makes the same angle to the surface. Let's do an experiment to understand the bouncing of light. Light rays show similar behavior, like the bouncing ball. Let's use this torch to understand it better. See, as the beam of light strikes the mirror, it bounces back in the opposite direction, making the same angle with the mirror. We can see the reflected beam of light properly because of the perfectly smooth surface of the mirror. If you keep changing the angle of the light source, then the angle of the light ray that bounces also keeps on changing. This can be seen by observing the illuminated portion on the screen. Let's understand some terms related to bouncing of light. The light ray from the torch strikes the surface, making an angle. This light ray is called an incident ray. The point at which it touches the surface of the mirror is called the point of incidence. The light ray bounces back after hitting the point of incidence. This ray is called the reflected ray. An imaginary line perpendicular to the reflecting surface at the point of incidence is called normal. The angle between incident ray and normal is called angle of incidence. The angle between normal and reflected ray is called angle of reflection. Thus, when light falls on an object and bounces back, it is called reflection. Light rays are very disciplined. They follow certain rules when they strike a surface. Let's see our diagram. Here we can see that the angle of incidence and the angle of reflection are equal in each case. Based on this observation, scientists formulated the first law of reflection. The first law of reflection states that the angle of incidence is always equal to the angle of reflection for any type of surface. Also remember that the incident ray and the reflected ray are always on the opposite sides of the normal. To perform an experiment on the first law of reflection, let's go to the lecture page on our portal. Click on the Virtual Experiment section and explore. Periscope is a tool which is developed using the first law of reflection. Let us observe the working of the periscope in the Know More section. Now watch the movement of the torch. Observe that the incident ray and the reflected ray always lie in one and only one plane. The second law of reflection states that the incident ray, the normal, and the reflected ray always lie in the same plane.
Teacher, why do certain surfaces produce an image while others don't?
Do you see any image on this wooden plank?
No, I can't.
Now let us take a polished wooden plank. You can see a faint image on this. If I place a glass on top of the wood, we can see a better image.
Yes.
But it is still not very clear. I am not happy with this unclear image. I want a clear and sharp image. So I have silvered the back of the glass, and what do I get? I get a smooth, shiny surface, and I can see a clear image. A surface that is able to produce a clear image of an object placed in front of it is called a mirror. Let us look at the smooth and rough surfaces and see how light is reflected from them. We will see some animations using the K-yarn. If a beam of light strikes a surface, it reflects back. A beam of light rays is a set of light rays parallel to each other striking the surface. We can see that the reflected beam of light is also a set of parallel rays of light in case of a smooth surface. When the reflected rays are parallel to one another, it is called regular reflection. This is the first type of reflection. Here is a piece of wood with a rough surface. We can see that it is uneven and with lots of pits. When a beam of light hits a rough surface, the incident rays are parallel to each other, but the reflected rays do not remain so. Why are the reflected rays not parallel to each other? Look at the point of incidence for each individual ray. Each individual ray follows the law of reflection. However, the roughness of the material means that each individual ray meets the surface and has a different point of incidence. Let us consider the first ray. See its point of incidence. I will draw a perpendicular at the point of incidence, and then I will draw a reflected ray making the same angle as the angle of incidence. Now let us consider the second ray. See its point of incidence. I will draw a perpendicular at its point of incidence. Now I will draw a reflected ray making the same angle as the angle of incidence. See the direction of the second reflected ray. Is it parallel to the first reflected ray?
No, it is not.
In fact, if you see carefully, the incident rays are all parallel and concentrated in a beam. But see, none of the reflected rays are parallel to one another. All the reflected rays are going in different directions. When individual rays of light reflect off any rough surface, they travel in different directions. The reason is that on a rough surface, the normal line at the point of incidence is different for different rays. Since the normal is different for each incident ray, the direction of the reflected ray will also be different. Some of the reflected rays enter our eyes and others are spread out. That is why we cannot see any image on the wood as it is a rough surface. When reflected rays of light bounce off in all directions on a rough surface, it is called diffused or irregular reflection. In diffused reflection, the reflected rays are not parallel and hence no image is formed. This is the second type of reflection. If you want to see some real-life examples or try out activities at home on what we have learned so far about rough and smooth surfaces, visit our portal Il&Fs.com. So, now do you understand that the quality of the images that is formed is based on the type of surface, rough or smooth?
Yes.
So, light rays from a source fall on an object. When an object is opaque, light rays are reflected back. Some of these reflected rays enter our eyes and we see that object. If the surface of an object is completely smooth, a bunch of reflected rays entering our eyes are parallel and we get images on the surface of the object. If the surface of an object is rough, reflected rays travel in different directions and the image cannot be formed on such a surface. Depending upon the degree of smoothness, the quality of an image is decided. Let's now do some moon gazing and learn from nature. It is true that the moon does not emit any light of its own, but it shines due to the light it receives from the sun, which it reflects back. Let us watch how the moon looks when seen in a mirror, the water of a calm lake, on a disturbed water surface, and finally on land. Let us observe the moon in a mirror. We can see a perfect reflection of the moon. The reflection is regular. If the moon shines on a calm lake, a clear reflection of the moon in the water can be seen. But this image of the moon in the water is slightly distorted compared to its reflection in the mirror. This is because even a calm lake has some ripples on its surface. Now let us see an image on a disturbed water surface. Here the image looks much distorted because the surface of the water is wavy. The reflection is more diffused and less regular. And when the moon is in the sky and you look down on the ground, can you see an image of the moon?
No.
Why is it so? It is because the surface of the land is very rough. The reflection is completely diffused. So now you know why you can see your face in a mirror and not on a sheet of cardboard. We learned the laws of reflection of light and tried to understand them by seeing some day-to-day applications. Let us solve some examples. Here is the first one. Find out the value of the other angles. If the value of the angle between the surface and the incident ray is 45 degrees. We know that the normal is perpendicular to the reflecting surface. That is, it forms 90 degrees with the reflecting surface. So, if the value of the angle between the surface and the incident ray is 45 degrees, the angle of incidence is 90 minus 45, which is 45 degrees. Now we have just learned that the angle of incidence is equal to the angle of reflection. So, the angle of reflection is also 45 degrees. Once we know the angle of reflection, the angle between the surface and the reflected ray is again 45 degrees. Okay, now find the other angles if the angle of incidence is 30 degrees. Since the angle of incidence is equal to the angle of reflection, let us arrive at the angle of reflection first. The angle of reflection is equal to 30 degrees. The normal is perpendicular to the reflecting surface. That is, it forms 90 degrees with the reflecting surface. If the angle of reflection is 30 degrees, then the angle between the reflecting ray and the surface is 90 minus 30, which is 60 degrees. Similarly, the angle between the incident ray and the surface is 90 minus 30, which is 60 degrees. If you like to solve more examples, they are available on our portal www.Il&Fsets.com. So children, let's revise what we learned today. Light rays behave in a disciplined manner and follow the two laws of reflection. They are: the first law of reflection states that the angle of incidence is always equal to the angle of reflection for any type of surface. The second law of reflection states that the incident ray the normal, and the reflected ray always lie in the same plane. There are two kinds of reflection: regular and diffused or irregular. Remember to observe and understand all that we have learned about light and reflection. Thank you, children. Do visit our portal www.ilfsets.com to learn more about reflection. We will now meet in the next class. Till then, bye-bye.